now?
Hi, I'm Luís, Espírito Santo.
I'm João Pedro.
Yeah, and the problem is the same, that it's credit fraud classification. The dataset is the same, so we're just gonna present real quick this first part of pre-processing and dataset presentation. So we have a not scaled, some features that are not scaled, like the time and the amount. So we have used some, also we have an unbalanced dataset, and we did the splitting, and we can see that if we try to print a correlation matrix, it's not representative of this dataset, correlations between the features of this dataset, because it's unbalanced. And then we tried some scalars that are already implemented in scikit-learn library. We tried with the standard scalar and some composition of scalars, but we decided once we could not make a good option based on anything, we just tried for a first approach use the robust scalar for amount and time. We also tried to drop the time column because we found out that it's not needed for classification purposes. So it was not representative or important for classification. For balancing, we used SMOT and Tomek for this approach, but we also tried to use SMOT, ENN, and some other combinations of oversampling and downsampling techniques. Well, so we have now a balanced data set, and we have now a correlation matrix that show us some real correlations, as such as correlation between some features as D7 and D7 or D6. So then we use a grid or dump approach to just choose some classifiers. We just use this balanced data in some classifiers with a split, and just choose the better recall F1, the better results with better metrics, and that two were the random forest and multi-layer perception. And we studied these two classifiers in specific because we choose this using this dump approach, not using cross-validation. Then we try to use cross-validation after choosing these two, and testing these two with hyperparameters. We tried some random cross-validation to ensure that these two classifiers were a good decision for our problem. And in terms of accuracy, they were really good. For tuning hyperparameters, we tuned the hyperparameters of random forests or two-class decision forests. Yeah, in Azure. It's the same thing almost. It's a little bit different,
yeah,
but it's not. I think it's not really relevant.
Yeah. Some of the hyperparameters are the same as the ones in scikit-learn. So we actually we tuned the hyperparameters in Azure, and then reported the best hyperparameters to the sklearn classifier.
Yeah,
It was easier to do it on Azure. That's why you did it like that.
sorry. It was easier.
Easier and faster.
Yeah, and faster.
Okay.
Yeah, because if we try to optimizing the hyperparameters in our computer, it would take too long.
Oh, okay.
Yeah, that's why we tried in Azure. So we just had the time to tuning the hyperparameters for random forests. We supposedly want to do it for multi-layer perceptron, but we did not have the time to do it. But we just tried to use it to tune it for F1 score. So we have to tune the hyperparameters for a metric, all right? We choose the hyperparameters that have the higher value for this metric. But also we tried to do it also for recall metric because we wanted to just have a little bit higher recall. The results we're gonna be explained by João.
Yes.
With his
To
computer.
do a better computer switch.
Yeah. It's fine.
Sabes como é que isto faz aqui? Isto acho que está a fazer extend.
Isso é extend normal. É simplesmente arrastas.
Isso é Windows.
Mas é um
procura disso.
Isso é um Ubuntu, não?
É.
Não sei. Não faço ideia.
Tenta arrastar.
Displace.
É displace.
Até isso arrastaste.
Sim, podes só arrastar.
Yeah. So, as he said, when we were tuning hyperparameters, we found out that our local computers were a bit slower, and yeah, a bit slower than Azure ML Studio, and we also wanted to, since this workshop also included some Azure ML Studio learning, we wanted to do use some of its features. So, as you can see, we have an experiment running right now, which is, but this actually serves to show you how we did hyperparameter tuning in ML Studio. So
1 hour and a half?
No.
it
I
starts
think
at
it's
1 hour. It's because this software is buggy. So.
Yeah.
If I start running, it starts at 1 hour. So. But what we did was we actually there's a tutorial online on how to do cross validation with parameter sweep on Azure.
So that's quite resource needed because you are doing a lot of processing.
Yeah.
It is. So we put our classifier here. We have already done this for the decision forest, and I will show you the results later. So for now we are training the two-class decision jungle. We, instead of being just I can't click right now because it's training, but instead of the trainer mode being the standard, it's a parameter range, and I can give it a set of hyperparameters for it to make a random sweep and evaluate which come out with the best hyperparameter combination for the training set. So here I can tell you to do a random sweep, and the number of sweeps we set it to 5. And here is the metric, as he was talking about, on which the classifier will be tested to find out which hyperparameters are the best for, in this case, recall. And then we can score the model and evaluate it against our test. This dataset, this training dataset, is scaled and balanced, and this one is scaled, but it's not balanced. So this one is on this dataset. As he said, we have run Smote with Tomek, and on this one we haven't. It's just a 20% random split we did at the start. So I can show you the results for when we did, because before we trained the two-class decision forest with several hyperparameters, and when we tuned for f-score, the results that it shows us come in this form. Which this is actually an ordering of the 5 runs that it did with the random sweep through the hyperparameter combinations, and this was the best one. It's ordered by F score. This was the one with the best F score. Yes.
Yes.
And these were the hyperparameters. With this one, we were able to achieve these
values for tests.
These values, yeah.
When evaluating against the test set.
Yes. So actually, this is interesting because compared to the other approach, we have more false positives. So more instances where the classifier said that it was a fraud when it actually wasn't. The transaction was licit, but our approach is more secure, in which it has less less false negatives. So it will
find more frauds.
Yes.
Are frauds. Yeah.
Yes, it will find more frauds.
So how much time it took to run
I
this?
think it was like
20 minutes.
Yeah, 20 minutes.
About
half an
20
hour,
minutes.
Yeah.
Okay.
It's not that much. The jungle is taking too long. It's like
What is too long?
1 hour.
Okay.
Yeah. Before it was for 40 minutes, but
40 minutes.
no, I stopped it because I thought this was above the 1 hour.
All right.
Then it wasn't. But
Yeah, but it's taking.
It's a
pretty
not
much more.
not documented feature.
Yeah.
yeah.
But yeah.
Yes. So then we tried, because the thing that we still wanted to do was in the final results, the metric that we still have to improve is recall, without of course sacrificing much of the others, because we could have more false negatives that way. But so in order to do that, instead of optimizing for F score, and I will show you. Yeah. So basically, in here we changed it from F score to recall. But on those results, even though we had a different set of hyperparameters, which could give us 1 recall in the training set, recall of 1. This didn't translate to better results on the test set.
Yes.
So we then have the results for recall. I think they're still here because because then after getting the hyperparameters tuned, we can extract them. Which is the images that you see here, and then we can just copy the hyperparameters to
Yes.
to the standard classifier, and this will be faster that way. So we have put here. We tried several of these combinations.
So what
We tried several
was
of
your
these
best?
combinations.
What was your best
that
shot?
One, that one which we showed before was the best shot, because on the training for recall.
Sorry, the best one was when you optimized the F
To
score.
F score, to
Yeah, the
F1
F
score.
score.
Yeah. When we tried to.
But you try to optimize to recall. Right?
Yeah, we tried, but the results for the data sets.
I can't show them right now, but
do you have it?
I think I don't have it, but
Yeah.
they were worse.
Yeah,
we
for the training set were better, but for the test set were worse.
Yeah, so they didn't generalize.
Yeah, it overfit the
Exactly.
training set. Yeah.
Yeah.
So we just chose the
one-
F1 score.
Yeah, the F score. So this was the best score because the F score can capture more metrics, because it has it's between the precision and recall, so it generalized better.
Yeah, I think one curious thing is that do you have the recall tuning hyperparameters? Recall tuning. It's tuning. This is
for F score. But I can show you.
you have that's for recall. The second best with the best recall is the hyperparameters that we found out in the F-score
Okay.
tuning. So we thought that this hyperparameters must be really good because it optimized the F-score and also almost optimized the recall. So we're trying with another classifier. Just have we showed it to you with jungles?
Yeah, with the
decision jungles. But yeah, we have not
still
results.
a tuning,
yeah,
but
it's still
that
tuning.
Okay,
maybe
it's still running.
yield
Yeah.
better results
Okay.
possible.
All right.
So great.
Yeah. Exactly.
So thank you very much, guys.